This recording will describe the persist-suppression ratio trend panel. The suppression ratio does not attempt to identify a burst suppression pattern. Persist includes the calculation and display of quantitative measures intended to monitor and analyze EEG waveforms. These quantitative EEG measures should always be interpreted in conjunction with review of the original EEG waveforms. Persist does not provide any diagnostic conclusion about the patient's condition to the user. To describe the suppression ratio trend panel in Persist, we'll use a recording that demonstrates a burst suppression pattern. On the left is 10 seconds of EEG, and on the right is a suppression ratio trend panel showing 2 hours of analyzed EEG data. I'm going to begin with the suppression ratio trend and then describe the other trends on the panel. This trend displays time on the x-axis and the suppression ratio measure in a percentage on the y-axis. I have adjusted the scaling to 0 to 70% to better show the changes. The graph includes blue and red lines representing the left and right hemispheres respectively. The higher the line on the graph, the more suppression in the recording. The suppression ratio does not indicate a burst suppression pattern. The suppression ratio trend evaluates each EEG channel or combination of channels for periods in which the amplitude of the EEG is suppressed, in this case below 3 microvolts baseline to peak, for greater than 1/2 second. The duration of all EEG segments meeting these criteria over a 10-second period are added together and a percentage is calculated. For example, if 3 seconds of EEG were suppressed in a 10-second epoch, then the suppression ratio for the epoch would be 30%. Because the suppression ratio often fluctuates from one 10-second epoch to the next, it's usually displayed, like here, as a 60-second running average. This produces some smoothing of the result. Paging through the EEG at this point, we see a typical burst suppression pattern. If we move to a section where there is a lower suppression ratio, and again page through the recording, we see shorter periods of suppressed activity. The top two graphs are the AEEG, or amplitude integrated EEG. The AEEG trends represent the smoothed average amplitude of the EEG envelope in the left hemisphere in blue and the right hemisphere in red. The y-axis scale is linear from 0 to 10 microvolts, and then is logarithmic from 10 to 100 microvolts. This somewhat unusual scaling was originally adopted to allow the EEG output to nicely represent the large typical dynamic range of EEG amplitudes seen in clinical practice. Changing low amplitude patterns can be seen well due to their linear scale at the low end of the graph, while the log scale in the upper half of the graph allows good representation of high amplitude activity, such as seen in many seizures. A distinguishing characteristic of this recording is the AEG looks essentially like a wide band. This type of AEG pattern is characteristic of burst suppression. So when seeing the combination of this type of AEG pattern, along with a relatively high suppression ratio, you would expect to see the burst suppression pattern that we see in this EEG. I'm going to change the time scale from 2 hours to 15 minutes. By doing this, we see that the reason for this wide band is that there are alternating periods of high and low amplitude activity. I'm going to switch back to a 2-hour window. When the suppression ratio decreases over here, we see that the AEG trends become less dense near the bottom and denser near the top. This corresponds to more high amplitude activity for shorter periods of suppression. Moving forward a few pages, when the suppression ratio falls to near 0, here, we see continuous high amplitude activity. The last trend on the suppression ratio panel are the rhythmicity spectrograms for the left and right hemispheres. These trends are included because the other trends on this panel are purely measures of amplitude and provide no information about the frequency or rhythmicity of the EEG data. These trends show the frequency and power characteristics of primarily the rhythmic components of the EEG. Time is shown on the x-axis, frequency on the y-axis, and the EEG power is shown as colors, with darker colors being higher power. I'm going to again change the time scale down to 15 minutes. Clicking on an area that is dark on the rhythmicity spectrogram corresponds to regions of the EEG with high activity. Paging to the EEG we see a correspondence between the regions of high activity and dark patterns on the rhythmicity spectrogram. I'm going to change the time scale back to 2 hours. Where the suppression ratio decreases, we see an increase in rhythmic activity, and that increase is primarily in the delta and theta bands. One last feature that may be helpful when using the suppression ratio trend is to set numerical value notifications. These can alert you when conditions are met. To do this, I'm going to right-click on the numerical panel, Notifications, and then select a new notification. I'm going to add a new suppression ratio trend. I'm going to set an upper and lower limit of 10 and 65, a minimum duration of 30 seconds, and I'm going to show the numeric values. I'm going to do the same thing for the other hemisphere. Lower limit, upper limit, 10, 65, 30, and show numeric values. This does a few things. It adds the numeric values to the numeric value panel, and it adds dotted lines across my graph so I can see when the suppression ratio exceeds the limits I have set. As long as the suppression ratio at the time indicated is within the range, the numbers appear in green. When the suppression ratio falls outside the range, the numbers appear in orange to let me know that it has exceeded the limits I have set. Additional information is available within the help file in Persist by clicking the question mark on the left side of the screen. If you have additional questions, please feel free to contact us at support@persist.com.